This is a tutorial for the Applets. So I Google PhET and PhET, and usually as the top one, click on Play with Sims, go to Physics, and Light Radiation makes sense if we're in the Optics unit. And this is the one that I start first, bending light, which is Snell's law, and then gonna go to Geometric Optics, which is the thin lens equation. I have them open already, so here you can click on Run Now, but as I said, I've got them already open. So here it is, that's the screen that's going to come up. Push that red button here and you get light out from the laser, and you can see the refraction here into the water, and you can see the reflection of the water air surface, and it's fainter, and we're familiar with that when we look in a window or when we look in a on a water surface, that we do see some reflection as well besides the refraction. Then we can turn this one here by grabbing it. We can change this to a wave, and that's how it looks like. For measurements, though, the ray is better. Grab the protractor and put it exactly there, and then you can measure the angle of incidence, 70 degrees apparently, and here 70 degrees for the angle of reflection, and then down here looks like 45 or 44 degrees for refraction. You can change the material down here, glass or mystery A, mystery B. You can change the material up here, for example water, and then down here to air, and now you're shining out of the water. We can measure the intensity here and here and here, and that's basically it as far as this intro window is concerned for bending light. Go to Prism Break. Again, turn this on here. Because we're going to deal with prisms, I just grabbed this one here. It's probably better to change to white light at this point. This one is not a laser anymore. Again, we can turn this one here, or we can move it any direction here. That wasn't possible in the other one. The other one we could only turn it. Okay, we can turn this one here by grabbing this corner. We can change to multiple rays. Perhaps at some point I say make sure that one of these prism edges, the one facing away, is vertical, and then this vertex here is pointing into the light, and we get something like that. We can show reflections. We can show a protractor if we need it. There. Put it, for example, there where it's coming out, and turn it. We can change the consistency of this prism here. Make it another material. Move it out. Get something else. There you go. Oh, that's why it took so long, because it needs to calculate all these rays. And I can't even move this away here anymore because there's just too much stuff. I'm just trying to move this away and I can't anymore. Oh, there we go. Good. There. Okay, so that's how you work this one. Then the geometric optics. This one here. Of course, yeah, click on this one and then run. And again, I have it already opened. So it says here, move me. I advise to move it in such a way that the eraser touches the optical axis. You can change from these marginal rays to principal rays. In that case, make the diameter bigger. And the instructions are there to do that. Many rays. You can move this closer or further away. Go back to principal rays. Perhaps take a second spot point. You can move that around. can change the diameter. You can change the refractive index. That of course affects the focal length. I'm going to click the second point away. It's easier to see. So refractive index affects the focal length, and so does the curvature radius. You can click on screen and then you get a lamp. You can move the screen. There is that image from the lamp's bulb. I'm going to put it back to the pencil. You can change the object. Smiley face, I guess. But I like the pencil. Click on a ruler. Measure the focal length, for example, always to the middle of the lens. The objective distance to the middle of the lens. The image distance to the middle of the lens. Let's see, make curvature, for example, really thick. I do explain this one here in the instructions. Respectively, I could explain it right now. In order to have the light refracted correctly, what we do in textbooks and in this applet apparently is that it is refracted in the middle of the lens and it comes out right, but of course that's not proper. Inside the lens it's not refracted, it's refracted on the surfaces here and here. So if I was to draw this on the board, I would do it actually exactly like this, and then I would take an eraser, erase this out, and then make a straight line from their surface to that surface here, so from these 2 points, and that looks more correct. If we do it this improper way here, which is, by the way, more simple, that's why we do it, or if we do it the proper way here, which is more complicated, the outcome is virtually the same. The differences are so small that we always use the more simple way, but I want to point that out, that yeah, the light actually refracts on the surfaces, not in the middle. And then you take the measurements here. Let's see, example over here. If you're within the focal point, you don't get a real image, so you turn on virtual image, and then there it is. There's the virtual image at this point. You use it as a magnifying glass, you still can measure distances. Okay, and that's the introduction for the Geometric Optics applet.